Hello everyone, and welcome to a new session for Computer Science 1. Today we are going to go over Chapter 3, which is Expressions and Interactivity. So Chapter 3, the topics that we are going to go over are the CN object. We are going to go over some mathematical expressions and working with them. We are going to go over type casting. We are going to go over assignment, multiple assignment versus multiple assignment and combined assignment. We are also going to go over formatting output and basically that is it. That's it. So we're gonna go over these topics in details. Let's start with the CN object. So the CN object can be used to read data typed from the keyboard. So you already saw the cout object, which is displaying data from your program to the screen, which stands for character output. The CN object is a character input. So you basically read from the screen into your program. You read data that the user enters via the keyboard, and then you take that data and you store it in your variable. So most programs, the majority of programs ask for values in order to operate, in order to process. So there has to be some input from out of the program, whether from a file or from the user, and that's called a stream of data. It might be from the network. So there has to be some input in in a stream fashion, and your program, when you build your program, you're gonna read that stream of data in parts or as a whole, and then store it in variables in your program so that you can use it at later stages in your program. So just as cout in C++ works, it's a standard output object provided by the language. The CN is also a standard object. It's provided by the language. It reads an input from the console or from the screen or from the keyboard, and you can look at program number 3-1, which is on page 88. So let's go ahead and actually type this really quick. So what they are trying to do here is they are just demonstrating how the CN works. So I'm gonna go ahead and declare an integer called length, another integer called width, another integer called area. This way of declaring variables using the comma instead of the semicolon means all these three are of the type integer. Then I'm gonna display, I wanna prompt the user. I don't want to run the program and then the user doesn't see anything and doesn't understand what is expected from the user. You always need to prompt the user, hey, hello, welcome, please enter value for whatever, X. Please enter student ID. Please enter the area. Please enter the height value. So I need to prompt the user. This program calculates the area of a rectangle, for example. End L. Finish. Then I'm going to tell the user what is the length of the rectangle. Now notice CN the opposite operator into length. Then I'm gonna ask for what is the width of the rectangle. And then again, Cn, the opposite operator into width. Now I'm gonna say the variable A or area equals to whatever length multiplied by whatever width. And finally, I'm going to see out the area of the rectangle is area, whatever is stored in this variable, and L. So notice, as a student, I always remembered that I can imagine this operator as an arrow. So I'm sending this literal value to the cout object. Here, it's the opposite. It's an arrow from the Cn object into my variable. So the data flows from the Cn, from the screen, from the stream into my variable and gets stored in my variable. Same here for the width. Then I'm saying this area that was declared here equals to whatever is stored in length at this point at line 19. Meaning at line 9, it didn't store anything. At line 14, it got assigned a value. And now on line 19, it's storing a value, whatever was entered by the user. Multiply, remember the arithmetic operators? This is the multiplication operator. Multiplied by the width. And finally, I am displaying the area, whatever value is stored in area at this line, at 21. So your program always, you probably know by now, it goes top to bottom. The execution is top to bottom, line by line. Let's run this. And we're gonna see if here is the prompt. This program calculates the area of a rectangle. What is the length of the rectangle? I'm gonna type 10. Then it's gonna ask me what is the width of the rectangle. I'm gonna say 20. Then it's gonna tell me the area of the rectangle is 200, which is correct. 10 multiplied by 20 is 200. I need you to know that you can step through your code. This column here, this is where you can put what's called a breakpoint. Breakpoints allow you to stop the execution at this specific line. For example, if I put my breakpoint here, notice it's this gray column, not the black, the gray. If I put a breakpoint at line 16 and then I run my debugger, notice my program will run, so it's gonna ask me for the length. I'm gonna say 10. Notice now the program stopped executing. It didn't do anything. It stopped. And now it's waiting at this line. Notice the arrow, the yellow arrow. So it's waiting on this line. This allows me to see, for example, I can hover my mouse on length and it's going to tell me that length is storing the value 10 in it. So this is a debugger feature. It allows me to debug my code. And if there is a bug in the code, if there is any issue, problem in my code, I will have to break in different points and then monitor, check what's exactly happening and if it is the expected behavior. If I enter 10 and then I come here and I hover my mouse and I see 30, then I know that something is wrong in this line. I enter 10, but length is storing 30, so here is the problem. So this allows you to debug. Now, not just that, I can also step through my code line by line. I don't have to continue executing the entire program. I can click F10, or you can click this one, step over. I'm trying to show you. So step over, see, F10. Step over means execute this statement. So now I'm gonna click it. Notice it executed this statement and it displayed it. So now it's waiting at this line. So I can tell it again, okay, execute this statement. Now that it executed this statement, the screen is waiting for an input. So I tell it 20, and now the flow or the control is back to this line. So this line got executed and now it has the value 20. Now I'm about to execute this line. So I'm going to click F10, 10 multiplied by 20, area becomes 200. So this line did not execute yet, notice. Right when I click F10, then it gets executed and it displays. So again, I can put C out here. I can put a breakpoint here at this C out, at this C out, and then I can restart my program. Notice it's gonna execute up until this line. What is the width of the rectangle? So now it's executing. What's the length? I'm gonna say 10, and boom, it stopped. I can hit continue, which is F5, and if I hit continue, it will run all the lines up until the next breakpoint. So I'm gonna hit continue. It's gonna tell me, okay, what's the width of the rectangle? I'm gonna say 20. Now it stopped. It didn't stop at this line. It didn't stop at this line. It stopped at my breakpoint. I can execute, I can continue, and it will display and finish. So this is the idea so far, basic idea of the CN object. Let me move this stuff here. The next thing in the book that is trying, what the book is trying to communicate to you is entering multiple values at the same time. Sometimes you're not gonna see a program that looks like this. What is the length of the rectangle? One line. What's the width of the rectangle? One line. You might see a prompt. What is the length and the width of the rectangle? And then there is one CN statement that reads multiple values. And the way it works is, I'm gonna remove this, for example, and then here I'm gonna say, what is the length and width of the rectangle? And then in the CN, I'm gonna read into this and followed by a new operator. Just like we did with the C out. Notice I can display multiple values. This one is displaying a literal value, then followed by this one, which is displaying a variable, then followed by this one, which is displaying an end line. So I can do the same. I can read from the screen into length and then followed by width. The CN object will stop reading once it encounters a space character or a new line character. Let me show you. I'm gonna run up until this breakpoint. So now my program is saying, what is the length and width of the rectangle? And it stopped at this line. So I'm gonna tell it F10. Now notice I'm gonna say 10 space 20, and I'm gonna hit enter. So the CN at this point, there was a buffer. It's called a keyboard buffer, like how I keep calling it a stream. So there is a buffer. Now what I just entered under the hood, it looks something like this. It looks, this is my buffer. This is the keyboard buffer right now. It has character 10, or instead of confusing you, let's make it simple. It has the value 10, it has space, it has 20, and then it has the new line. So my statement is CN into length, and then CN into width, semicolon. So what's gonna happen is the CN object will start reading up until it encounters a space character. Once it encounters a space character, it will stop reading, it will ignore the space character, and then it will take whatever it read so far and put it in length. Now I have a new operator. The CN object will continue reading. Once it encounters a new line, it will stop. It will ignore the new line, and it will take whatever value read so far and assign it to width. So the CN object, especially this operator with the CN object, stops reading once it encounters a space or a new line character. Once it counters space or a new line character, it will terminate, assign, and continue. So the termination of the of iterating the buffer or reading or consuming the buffer stops or terminates at a space character or a new character. Look what happens when I, instead of space, let's continue here and then stop it. Notice if in this case, continue, if in this case I say 10, enter, so I clicked enter, not space, notice the CN is still waiting for me. Why? Because this operator executed and it terminated at my new line. So now this operator is waiting for a value. So I'm going to click 20, enter again. The value is 200. So what happened in this case is similar. Instead of having buffer looking like this, my buffer basically looked something like this. So it was a buffer of data. It had the value 10 and then new line and then 20 and then a new line. So my statement was cin length into width semicolon. So similar fashion, it read up until the new line, right? Based on the definition, based on the rule, it will stop reading until it reaches a space or a new line. So it reached a new line character. So it will terminate, ignore, and assign 10 to length. It will continue reading up until, oh, another new line. So stop, ignore, and then assign 20 to width, and so on and so forth. The fact that there is a semicolon and no more insertion operator, then the entire buffer is basically, it has been iterated or done. So this is where the entire statement finishes and we move to the next statement, and then it gets displayed as 200. So this is for entering multiple values. And program 3-2 shows you an example for that. Now, I'm going to give you an example. I'm going to show you an example for entering multiple values that are of different data type. So for example, I'm going to say length and area are integers and width is double. So width is double. So this will still work. I don't need to change anything. But notice when I run, it's going to ask to enter length and then width. So it's expecting an integer and then a double. So I'm going to go ahead and say 10 at this point. 10. Oh, let's execute the statement first. 10, 20, enter. So now what happened is, although I entered an integer, but under the hood, this 20 was stored as 20.0, which is a decimal. So the fact that this is a double, it can carry. There is a place for decimal. But in this case, the decimal is zeroed out. Another example is execute. Let's stop at this level because I want to show you. I'm going to say 10 and then 20.3, enter. Now notice the 10 goes to the length and then 20.3 goes to the width. So the CN object and this operator specifically, the fact that this variable is declared as a double, it allowed the dot and the 3. It didn't terminate reading at this character. So the buffer under the hood looked like 10 new line 20.3 new line. So same to above, it read up until the new line, assigned 10, and then read up until the new line, assigned 20.3. The fact that this variable under the CN statement is declared as double, it allowed it. However, notice if I swap the methods, the values. If I swap the values, for example, I enter decimal for the integer, notice it terminated. It didn't allow me to enter the next value. What happened is length, because it's declared as an integer, the CN object grabbed the 10 part of this number, assigned it to length, and then the 0.3 was assigned to the width. So I need you to be careful that eventually all values should be entered in the right order, just so we don't get into this problem where you expect one value, but then they get stored in different in a way that you didn't expect. Let me speak about a little bit about this 29999. All double, we don't have control. So long story short, we don't have control how double values are stored under the hood. Under the hood, double values, the way computers store at the bit level, it can't store the decimal as is, but it can be very close. It can be closest to 3. So in this case, the closest to 3 is 0.299999999. There is a rule in C++ that you cannot compare two float points or two double variables if they are equal or not. Because two variables, even if you give them the same values, it's not guaranteed that under the hood they are exactly equal. For example, if I give a value, let's run this. If I give a value 0.3 and the next value is also 0.3, this might be stored as 0.2999999, which is very close to the 3. And this might get stored as 0.300000001, which is very close to the 3. So although it looks the same from the user perspective, also from the programmer perspective, although it might look the same, but they might be stored different. So if I go ahead and I say, hey, if grade 1 equals to grade 2, I need you to do this. They might be equal, but under the hood, they are not equal. So your statement will fail and your logic will be broken. So the rule in the language is you can check if you have to check two doubles to be equal, you need to build your code in a way that it checks that two doubles are nearly equal. So if the difference between these two doubles is 0.000000001 or 2, for example, then you can execute your logic based on them being equal. If the difference between them is 0.0002, that means they are very close to each other, so they are equal. So another rule is, if you don't need the decimal part in your value, do not use double. If your logic needs only an integer, then declare your variables as integer, just so you don't get into that problem. Because again, if I am typing one, for example, as an ID, but this one gets stored as a floating point or double point, it will not be stored as one. It will get stored as either 0.9999999 or 1.0000001. So it might confuse you, break the logic, confuse the program. So the rule, the second rule is, if you don't need the decimal part, do not store your values in a double variable. So this is for entering multiple variables. The next thing we need to go over is some mathematical operations. What I'm interested in, basically, one thing is what we mentioned last time, which is integer division. You need to make sure, or you need to be careful when you do integer division. Two integers will always result in an integer. If I divide 10 over 3, the result is 3. There is no decimal because I divided two integers. Even that the logic says there is a decimal, C++ does not store the decimal, just for the fact that both variables were integers. So one thing to consider, or we can wait on this topic on for typecasting, um about the integer division, and then you have to, or maybe we spoke about it before, where you need to convert one of them to be double. Yeah, so the solution is, if you need your double value, then at least one of the uh, 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 operand has to be a double or a float. So if you need a float, then one of them has to be float. If you need double, then one of the operands has to be a double. Then the result will become double. And we're going to speak in detail in typecasting. The next topic I need to speak about is operator precedence. It's called operator precedence. You can, right now, here in this equation, let's say, or mathematical expression, it's only one operator, but it's possible to build expressions with several operators. For example, I am going to type this. So I'm going to say, for example, double answer, let's say answer equals 17 plus 9 plus 21 plus 5. And this will work. So this expression is multiple operators and multiple operands. Now, in this case, all the operators are the same. So there is no precedence here. Precedence as in precedence. So it's called operator precedence. Let's move down for a new topic. Can I move this guy? You cannot move it. I can't move it. Okay. So, operator precedence. And here we mean the mathematical operators. So remember the arithmetics: plus, minus, multiplication, division, and modulo. So one example was when I say answer equals 17 plus 5 plus 21 plus 6, for example. This is completely legal. This is allowed. Now, the fact that they are all the same, then there is no precedence. But some expressions are not very straightforward. For example, let's start escalating. Let's say answer equals 12 plus 6 divided by 3. So what value would be stored in answer in this case? 6 is used as an operand for both these operators. 6 is used in the addition and also used in the subtraction. In this case, answer could either be value this subtract over 3 or value this added to 12. So what the program will do or the language will do, just like the logic in real life situation. The logic for this expression in algebra is to execute this portion first, and then the result becomes an operand for this operator along with this operator. So this is where precedence come from. You have precedence. You have operators that have higher precedence than other operators. There are operators that get executed before other operators. Let me see where the book speaks about this. So the topic is in 94, but I'm looking on page 94, but I'm interested in the table for precedence. There was a table somewhere that tells you oh yeah, it's table 3-1 on page so this is 94, this is page 95, table 3-4. They made the table smaller on this edition. So so what they are trying to tell you is in any expression, let's remove these guys. So when it comes to arithmetics, the highest precedence means I'm gonna say highest like this. So the highest precedence means the one that gets executed first. The highest precedence is for the negation, unary negation. This is when you say, for example, answer equals -12. -12, for example, +6. This is not subtract. This is called unary negation. So it's the positive 12, the opposite. The negation of the positive 12 becomes -12. If you have this expression, even more expressions, even more operators, I mean, let's say subtract by 3, multiply by 4. If you have this kind of expression, the highest precedence here is the negation. The first operator to get executed is this one. Basically, it tells the program, hey, the value 12 negated, -12, so now the result under the hood is actually -12. So the highest precedence is for the negation. This is negation. It's not subtract, because you might confuse it with subtract. So negation, it gets executed first. Imagine, for example, when it comes to negation, multiply, for example, -4. So the multiply doesn't get executed first on the 4 and then the result gets negated. Yeah, like 3 times 4, 12, and then -12. No, in C++, the negation gets executed first. Now, you might not see the difference, but you need to know that the highest precedence is negation. The next is the multiplication and subtraction and modulo. And the final or the least precedence is the addition and subtraction. So you can break this rule. This is the default behavior. So the default behavior in the C++ is this. First, this gets executed, then these gets executed, then this gets executed. You can break that rule. For example, answer, also similar to algebra. If I have 12, you might see something like this in the test. I'm going to give you an expression that says 12 plus 6 multiplied by 4 over 5 minus 3 modulo 2. And I want to ask you what's the value for this expression. So the value of this expression based on this, we're going to execute this first. So it becomes -3. Now, these need to go next, right? They need to execute next. However, here I have multiple ones. So I have multiple operators of the same precedence. In this case, the execution is left to right. So I start by the most left operator, and then I move my way on to the right. So in this case, I'm gonna say it's equal to 12. I don't need to do anything with this operator, not yet. Then I'm gonna multiply this 6 by 4, 24, and then modulo 2. And now next, so from left to right, 12 plus 24 over 5. This is an integer, this is an integer, so it becomes an integer. In this case, it's 4 minus 3 modulo 2, and then the modulo last thing in this case, so 12 plus 4 minus before the minus 3. So 3 modulo 2 is 1, so minus 1. So if I take 2 from the 3, its remainder is 1. So now I'm done with the higher precedence operators. So now I have addition and subtraction. Both these operators are of the same precedence. So I also go from left to right. So equals 16 minus 1 equals 15. So this precedence thing can be overruled by you. For example, if I have answer equals 12 plus 5 subtract by 6 divide or subtract divide then subtract by 2 multiply by 3. We know how this goes, but I can overrule or override the default behavior by providing brackets. So if I provide parentheses, that means I'm telling my program to execute whatever is inside the parentheses first. So in this case, the first thing that gets executed is whatever is inside the parentheses. So it becomes like this. Now there are no parentheses, so I start with the higher precedence left to right. So it becomes 12. 5 over 4 is 1 multiplied by 3. Then I move my way to next. So this is when it comes to operator precedence and um, associativity. Those are on page 95. Let's see what's on 96. Yeah, they speak just, they give you an idea just so you don't get confused. So after they speak about grouping with parentheses, they speak about examples of between algebraic expression and then the operation basically, and then the C++ equivalence. So algebraic, for example, 6b. In algebra, 6b means 6 times b. In C++, it's 6 asterisk, whatever variable b is. Another is, in algebra, you can write this one. That means 3 times 12. In C++, it is 3 times 12. You can surround them with parentheses. And the last example is 4x, y. This means 4 times x times y. So in C++, it is 4 asterisk, whatever variable y, whatever variable x. Next topic in this chapter is telling you that you cannot use exponential in C++. In order to use exponential, the power, for example, 2 power 4. 2 power 4 in C++, so answer equals 2 is not asterisk 4 because this means 2 times 4. And it's not this operator, which is shift 6. So the shift 6 operator, which is like a hat, so answer equals 2 power 4. This is also wrong. This is not 2 power 4. This is called XOR, I think. XOR, meaning we're going to go over it later. So so there is no exponential in C++. What is provided for you is a function called pow, and it takes two inputs. It takes the first input, which is the 2, and then the 4. So this pow function will return 2 power 4, basically. So it's two arguments. And then spotlight, this which is like a review and a checkpoint. Then they start with type conversion. When it comes to type conversion, there is a default behavior, and then there is like a programmer rule. So there is a default behavior by the language, and you can overrule or override those rules and provide your own way of conversion. By default, there is you want to think of it as rankings. There in all data types, in C++ data types. So I'm gonna go here and say type conversion. So you want to think of it as highest rank and lowest rank. The highest rank, you can remember it by thinking of its size. How many bytes is this data type means we'll put it in its respective area, the smallest to the highest. I and based on the size, and then range. So meaning it's if I want to speak about ints and double, so we're gonna go by long, for example, long double, because this is the highest size. Then you have a double. Then you have a float. Then you have unsigned, because this is range. So unsigned long, long int. Then you have if it's unsigned, so it's long, long int. So these two are the same size, but the range is different. This is from negative to positive. This is from 0 to positive. In that case, you can go by saying unsigned long int, and then long int. And finally, we can do unsigned int, and then int. So this is the ranking for these data types, okay? Meaning, anytime you are mixing these two data types in an expression, for example, I'm gonna say answer equals some long variable multiplied by some int variable, for example. Anytime you're mixing these two, the automatic behavior is to promote. There is no demote. It's always promote. The language will come and check out, say, okay, this is long, this is bigger than int. So let me go ahead and convert this int to a long. Under the hood, they're going to be the same value, just like you see with 2 or 2.0. I know this is stored different, but it's considered 2.0. So 2 and 2.0, they are the same value, but they are stored differently. So, for example, long int and int, they are both stored as 2's. But this one is stored in 4 bytes. This one is stored in maybe 8 bytes. So you're going to have 16 bits just as zeros. So whatever these 16 for 2 bytes, then another 16 for additional 2 bytes. All of them are zeros. So this is for integer, and for long would be 8 bytes. So let's say these are 2 bytes, another 2 bytes, another 2 bytes, another 2 bytes. So since the value is 2, then the one here, the bit here is 1. So 2 power 1 is 0, 2 power 2 is 1. So the rest are zeros. So the values are the same, but they are stored different. So here we have 2 bytes, here we have another 2 bytes, and then here we have another 2 bytes. Here we have another 2 bytes, and one of them is 0, so 2 bytes. So both this long and this int, they are both storing the value 2 in them, but they are stored differently. They just have extra zeros. So the idea here, language C++ will promote integer to become long, and then it will multiply both of them, and then the result becomes long. This is what you need to know when it comes to type conversion and when it comes specifically to the default behavior. Anytime you mix, then one of them will be promoted to become equal or same to the larger one. Okay. Then there is the manual one. You can convert manually to whatever data type you want, and let me show you how. So let me go here and say double answer equals 2.3. Now I'm going to just display answer. In this case, it will display 2.3. Here it is, 2.3. Now I can tell it manually to convert this value to be integer, for example. And the way to do it, there is the C way, so the C language way, which also works in the C++ language, because C++ is based on C, so everything in C plus stuff. This is the C way of converting a number. So 2.3 will be converted to an integer and then assigned to answer. So now, although answer is double, but the value becomes 2. It loses the decimal, because before the assignment, I got rid of the decimal. The C++ way is, there are 3 ways, but the main way for now is static, cast, int, and then it takes a parameter. So static cast to integer or to character or whatever you want. For example, 65, if I convert it to a character and assign it to a character, it's capital A. In this case, if I execute my program, it will display 2. I told it manually to convert 2.3 to an integer. So this is manual typecast. The next thing you need to know from the book is topic 3.4, which is overflow versus underflow. So let me show you an example. Remember the range for short? For example, if I say short answer equals, the maximum range for a short is 32767. Now, if I come and say answer, or let's display it first, see out, answer, just so we see it on the screen. Then I want to say answer equals whatever Answer is +1. So I'm adding 1 to it. And then I'm going to display. Notice what happens. What happens is basically when a variable is assigned a value that is too large or too small uh, for that data type, then the variable overflows or underflows. In this case, it will overflow. And the overflow behavior, I'm going to show you, meaning it will go back to its smallest range. And this happens under the hood because if I go ahead and type, for example, imagine the range is from 0 to, let's say, 8, -8 to 8. Let's assume this is the range, meaning 2 power 1, 2 power 2, 2 power 3, 2 power 4. So this value is 1, this value is 4, is 2, this value is 4, this value is 8. So if I have a variable that has the value 8, that means it is 1, 0, 0, 0. Let's say, sorry, let's go with 16 just so we can give all values. So -16 to +16. If I have a variable of the value 16, that means all the bits are on. In this case, 15, just so 0 to 15 is 16. So let's say -15 to +15. So the variable 15 is all of them. Now if I come and add 1 to the 15, that means I'm doing this expression. 1 in bit representation is this, and 15 in bit representation is this. Now if I wanna add these two, 1 plus 1 becomes 1, 0. Remember the base 10 sequence? Every time you reach the end of the set, then you start over and increment. In this case, the set is either 0 or 1. So once I reach 1, I reset, I start over and increment, meaning let's say I have 3 bits. I start from 0, 0, 0, 0, 0, 1. Now it becomes like this. So if I add 1 to this one, then I reach the end of the set. So I reset and increment. If I add 1 to this one, then it becomes like this. Now if I add 1 to this one, it becomes like this. 1, and so on, so forth. So with that being said, if I add 1 to the 15, then this expression will become 0, and I carry over 1. 1 plus 0 plus 1 becomes 0, and I carry 1. 1 plus 1 plus 1 plus 0 plus 1 becomes 0, and I carry over 1. 0 plus 1, 1 plus 0 plus 1 becomes 0, and I carry 1. This is the signed bit. The signed bit is the negative. So if this sign bit is on, means it's negative. And if this sign is off, means it's positive. So this is where the overflow takes place. So it basically resets back to the set, and it becomes 111 with a sign object, with the, sorry, with a sign bit. Similar to underflow, if I have the value -15 and then I decrement by 1, it will underflow all the way back to the 15. So the book tries to communicate this to you with an example, which is on page 104 and 105. Then the book goes over typecasting, which we are done with. And then the book speaks about multiple assignment versus combined assignment. So multiple assignment means, so let's type it, multiple assignment. This means to assign basically the same value to several variables. So I can have three integers, for example. I can have int a, b, c, semicolon. Multiple assignment means I can do a equals b equals c equals 10, meaning the 10 will be assigned to c and also to b and also to a. And there is example in the book, which is like pretty simple. So this is what's called multiple assignment, meaning assigning the same value to multiple variables at the same line in the same statement. Then you go to combined assignment. So they are more like terms more than concepts. Assignments. Combined assignment means whatever I did earlier. I did answer equals answer plus 1. So here I'm saying if answer has 10 in it, so I'm telling my program I need answer to store whatever is in answer plus 1, so it becomes 11. Moreover, I can shortcut this by saying answer plus equals 1. This and this are the same. So here, this one, this operator means I need to store in answer whatever is in answer plus 1. And this operator has different versions. You have the addition, subtraction, multiplication, division, and also the modulo. So all the arithmetic operators has combined assignment operator. There is this operator, and then there is example usage. So this is the operator, this is the example, and this has equivalence, which is this one. So the operator, the usage, and then the equivalence for it. And this is what the book is trying to communicate. Next topic is, I think, which is the last topic. Yes. So the last topic is formatting output. You can format your own output. Imagine I have the value 2.12345. When I display the output, or when I display this to the output, I can format it in a way that, for example, I only want to show 3 decimal places, or I want to show all decimal places, or I want to show it in exponential format or notation. So we're going to learn how to format our output. So let's go to our code. Let's go to our code, and then I'm going to type some numbers. Let's see what they did here. Just so you follow the book, I'm going to start with the set precision on page 115, set precision manipulator. Set precision is a way provided by the language for you to choose the number of decimal points that you would like to show. For example, I'm going to go here, and then I'm going to say I need a double. Um, 10, number 1, and I'm going to give this a value. So I'm going to say 132.364, and then I'm going to choose a second number, and I'm going to say 26.91. Here, I'm going to say that this variable equals to number 1 over number 2. And there is no issue here. Both these numbers are double, so the result will become a double and will be stored in this variable. Now notice when I see out the variable as is, I'm gonna run my program. The default is to display 5 decimal points. Now, if these are zeros, it will not display 5 decimal points. So it will not display the zeros. It will display up to the valid value. Now, let's say this is ugly and I don't want to display 5. Even though I have 59, I don't want to display the 59. I only want to display, for example, 4.92. I don't care about this. Like dollar value. Dollar value, we only have cents. We don't have more or lesser significant digit. Let's say $4.92. In order to do that, first I have to include the library that provides me this functionality. And it's called IO-manip. So input output manipulators. This library provides me with a few functions that will help me format my output. The first function or feature is called set precision. So notice here at this point, I'm going to say set precision. And I'm going to say I need precision to be 2, and then I want to display this guy and L. So now this will display the default, and then this will overrule that default and specifically display only 2 decimal points. Notice, oh, it did display only 1. Strange. So I think it floored this, so it became 9-0, and it got rid of the 0. So let's do 3. Now it should work. So 9-2. Okay. So what happened is it floored. If I say 2, the 92059 is closer to the 9 than to the 10. So 92 is closer to the 90 than to 10. So it floored it. 92 became 90. And the fact that zeros get ignored, so it displayed 4.9. Now, if I tell it I need 3, then it will display 92. The 0 will be ignored. Interesting that it did this. Because the book shows different. Maybe Visual Studio changed it. Oh no, the book didn't show different. So set precision 2 shows only 1 number after the decimal. I'm looking at program 3-15. Interesting. Okay, so this is the idea. Now notice if I have like this number, I'm gonna display it with 5. I'm gonna tell it 5 decimal points. Although it only has one decimal point, but it will display only that 1 decimal value, even that I told it 5, because it will ignore zeros. Just this is just so you keep it in mind. So this is for set precision. And then the next thing with this IO manip is the fixed manipulator. So set precision manipulator sometimes does unexpected behavior. So sometimes it surprises you. Like now it surprised me, to be honest. So a lot of times this set precision surprises us in undesirable way. So when the precision of a number is set to a basically lower value, numbers tend to be printed in exponential notation or scientific notation. For example, let's do this. For example, let's do this program. Um, double day 1, day 2. And then I'm going to ask the user to enter, cout, enter value for day 1. Let's say it's some sales or whatever. And then cin into day 1. Again, cout into day 2. And finally, I'm going to say some value double total equals day 1 plus day 2. And then I will display the result. So I'm going to say cout um, um, display, let's display day 1 and L cout day 2 and finally cout total. Oops, I forgot to actually display day 1, day 2, and here it's total. Notice when I run my program, this is going to say enter first value. So I'm going to say 1321.87. For day 2, it's 18, for example, 69.26. So now it displayed this behavior by default, 2 decimal points. So now if I use the fixed manipulator, all floating numbers or floating point numbers that are printed will be displayed in a fixed notation. So it's gonna always be fixed. Basically, I'm gonna always tell my program, hey, I need you to display as is. Let's make a bigger number to make the point. Let's do way bigger number, and this will show us. So for example, for the first one, I'm gonna use a, a big number, 99. For the second one, I'm gonna use big one, for example. So it overflew, I think. And so here I didn't use the fixed operator. So now day 1, 145, double, it didn't display. Oh, because I didn't tell it. So because I didn't tell it, let's tell it. Set precision to 2. And this will show you the unexpected behavior. Here I'm telling it I need to display 2 decimal points. Yep, 2 decimal points. And I will execute. Might be I have to tell it fixed. 145.678.99 205.614.85. Okay, here it is. So I told it I need 2 decimal points, but it surprised me with this notation. I didn't ask it for this notation. I asked it to display the number as is with this decimal point, but it converted it. Notice 456 is closer to the 5 than to the 4. 456 is closer to the 500 than to the 400. So it converted this to 5. 1.5 exponential 0.5. So the fixed, when you use fixed, you're basically telling it, hey, do exactly what I'm telling you. Do not play around, do not change, do not do any default change in the format. I only need you to display it as is. So 145.678.99 and then 2.5, 205, 614, 85, and here it is. So it did exactly what I need. This is the fixed keyword. This is how it's used. The next thing is um, the show point. So remember when I said the zeros are not gonna be displayed? So imagine, now I'm gonna get rid of this because we no longer need it. Imagine I have day one equals 1.00000, and let's add one here. Now I'm gonna tell it to display without telling it to display actually precision. We can just display the value as is. So this yes has a value. I'm gonna create another one, for example, that doesn't have 1.2, doesn't have zeros. Now, one for two and one for this. So if I tell it set day two, so if I tell it set precision to 6, for example, something big, and then I display, it will, as we noticed, it will ignore all the zeros. The 4 zeros got ignored and the z and nothing in here, so it displayed it as is. The show point operator is basically telling it I need to show 4 points or all the points that are in my set precision. So here, if I tell it show point, now this will actually show the trailing zeros up to whatever my precision is. So here it is for 6, it's 5, 6, it's 5, and it showed the zeros. Sometimes you have dollar and 10 cents, or let's say dollar and in your value it's 1.1, but you want to show it as a dollar currency. So now this is $2.2. So now I'm gonna show it as a currency. As a currency, it will be displayed. Oh, let's add one. So add one. Now it will display it as a currency, $1.10, $2.20, etc. So this is for the show point operator. So far you saw fixed, show point, and set precision. The next thing I need you to know is set width. Notice if I display multiple values, for example, day one, day two. If I display these with a space between them, and let's add two more. This one is going to be 1 to 3. This one is going to be 2, 3, 4. Day 3, day 4. So now I'm going to display day 3, day 4. Both have a space between them. If I run, this doesn't look nice on the screen. Notice 1.1 and then space, 2.2 space, but then 1.123 space. So the 2 or the next value is not aligned with the respective column. This, I would like these to be in one column and then these to be in another column. This, in order to do this, I am allowed to use the set width function. So here, instead of the space, I can say set W, for example, 5. And then I can say set W 5. That means the width of this field is 5 characters on the screen. So if I do it in different spots or in all spots, then notice, oh, let's give it one more. Let's give it 6 because they are actually 6 values. So 6, 6. As a matter of fact, we can do 10. We don't have to be like a very close. So 10, run. So here it is. Now it looks better. It looks better because I told it I need this value to consume 10 characters on the screen, and then this one to consume another 10 characters on the screen. So I have up to 10 values, and my values will be aligned, will still be aligned. So this is for the set width character. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this value consumed or allocated 10 characters on the screen. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, another 10. Similar for this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it starts with the next one. So this is for the set width function. Notice the alignment is right. So right is justified, meaning within this width, the value is on the right side of this field. This is the default behavior, but I can tell it to be on the left. So now I might have to do it in both places, but let's see. So now it worked. So both values are on the left of the field. So 1, 2, 3, 4, 5, oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the field for day 1. I told it I needed it to be 10, so it is 10, allocated 10 on the screen, and I told it I need the alignment to be left, so the value is left of the field. And notice they are nice on top of each other now, better than the right alignment. I can tell one to be left and one to be right. So you can play with it, but this is the idea behind input output manipulators. So far, you know, set width, fixed, show point, set precision, and then left versus right. Right is the default, but you can still explicitly say right in case you start with left and then you want another one to be right. For example, here. So now, error. So now, one is on the right, one is on the left, and one is on the right of the field. Let's see what the book is telling us to do. The next is from this chapter is to work with strings and characters, but I think we are over the time, so I'm gonna keep it for next time. I will also need to go over random number generators. So this is it for today. Let me know if you have any questions.